I want to talk today about how we represent elements and the protons and neutrons in those elements in chemistry. And we're going to use as our example today carbon. And oftentimes you'll see carbon written with a 6 in the bottom left corner and a 12 in the upper left corner. And these symbols mean very specific things. They have very specific meanings. They convey a certain type of information. The bottom number is referred to as the atomic number. It indicates the number of protons in any carbon atom. No matter what else an atom has, if it has 6 protons, it's carbon. If it doesn't have 6 protons, it's not carbon. The number in the top corner is the mass number, and it indicates the number of protons plus neutrons in this particular isotope of carbon. Now, we can have different isotopes of carbon. Not every isotope of carbon has 6 protons and 6 neutrons. This particular isotope does, because if we have a total of 12 neutrons plus protons, and we have 6 protons, 6 plus 6 equals 12. In this particular isotope of carbon, we have a mass number of 13. Since we know that every single isotope of carbon has to have 6 protons, any carbon atom has to have 6 protons. As soon as we see that the mass number is 13, we know that it has to have 7 neutrons. And this atomic number sometimes is omitted because having the chemical symbol and the mass number actually gives us all the information we need to figure out the total number of protons and neutrons in this element. I also want to talk about how atoms are represented on the periodic table, because if you look at carbon on your periodic table, what you're going to see is not carbon 12 with a 6 down there or carbon 13. What you're going to see is something like this. Carbon with the 6 up there, and you might guess that that's the atomic number, and it is the atomic number. Again, any carbon atom has 6 protons. But this number down here, 12.011, it's close to the 12 from the carbon-12 isotope, but obviously it's a little bit different. What does this mean? Well, this tells us about the so-called average carbon atom. If you were to go out in the backyard and dig up some carbon atoms and look at them, what you would find is that 98.9% of those carbons would be the carbon-12 isotope. And 1.1% of the carbon is the carbon-13 isotope. So how do we talk about the mass of the average carbon that you just scooped out of your backyard? Is it carbon-12 or is it carbon-13? What we actually do is we take the average mass of all of those carbon atoms. We call this the atomic mass. And to calculate that, what we do is we take 0.09, actually I've got an extra 0 in there. It should be, and let me correct this, there should be only 1 0 there, no zeros there, and there should be 1 0 there. So it's 0.989 times 12, which is the mass of the carbon-12, plus 0.011 times 13, which is the mass of the carbon-13, and that comes out to be 12.011, which is the number you see on the periodic table, the average atomic mass of a carbon atom. Now, this is in terms of atomic mass units, which we'll talk about later. If we were talking about molar mass, we could also talk about this in terms of grams per mole.